Hello everyone, this is Tejashwini from Sri Venkateshwara College of Engineering. Today my topic is about Markov analysis. First, let us know the introduction of it. Markov analysis is a statistical technique used to model systems that follow the Markov property, where the future state of the system depends on its current state, not on its past states. It is particularly useful for analyzing stochastic processes that naturally means random processes that evolve over time. Next, key concepts in Markov analysis. I collected 8 key points. There are many other of it. First one is states, transition probability, transition matrix, Markov property, steady state probabilities, observing states, recurrent and transition state, time state and initial state distribution. First one is states, the distinct conditions or statuses a system can be in. For example, in a weather model, the statuses could be sunny, rainy, and cloudy. There are three possibilities. Transition probability. The likelihood of moving from one state to another state, represented as which is the probability of transiting from one state to another state. These probabilities are typically summarized in a transition matrix. Next, transition matrix. A matrix where each element represents the probability of transiting from one state to another. Rows in the matrix represent the current state and columns represent the next state. Next, Markov property. The principle that the future state depends only on the current state, not on the sequence of past states. Next, steady state probability. The long-term probabilities of being in each state when the system reaches equilibrium. These probabilities remain constant over time regardless of the starting date. Next, observing states. States that once entered cannot be left. Example, in a customer service system, exit might be an observing state. This is also very similar. Next, recurrent and transition states. Recurrent state. States that the system will return to eventually. Transition state. States that the system may leave and never return to. There is a difference between these two states. Next, time state and initial state distribution. Markov analysis can be applied to discrete time, that is, steps or distinct or continuous time in time flows continuously. A vector that represents the standing probabilities of being in each state. Next, applications of Markov analysis. Predictive modeling. Forecasting future states of a system. Predicting itself like predicting. Decision making. In Markov analysis, decision processes example, reinforcement learning. Queuing system. Modeling customer behavior in service industries. Reliability analysis. Estimating failures probabilities in systems. Next, let us know the conclusion of this Markov analysis topic. Markov analysis provides valuable insights into the dynamic of the system under consideration. By analyzing transition probabilities, we can identify patterns, predict future states, and determine the long-term equilibrium or steady state behavior. This approach is particularly useful in systems where the outcome depends on the current states rather than the past events. Next, these are all the key takeaways from the analysis. Conclusion is nothing but this will be definitely lost topic that as everyone know. Key takeaways of the analysis include means the likelihood of the transiting between the different states, that is one state to another state, the indication of observing or recurrent states if applicable. Remember, this is only for if applicable, not everywhere. The steady state probabilities, which reveal the long term distribution of system's state. Next, overall, Markov analysis serves as a robust tool for decision making and forecasting into various fields such as business, economics, supply chain management, and operations research. Its effectiveness, however, depends on the accuracy of the transition probabilities and assumptions of the Markov property. Further reinforcements such as incorporating real-time data or relaxing assumptions can enhance its applicability in complex dynamic systems. Thanks for watching. Thank you.